Hi again, everybody. This is a solution for the first problem from quiz 1. We did this before, and there was actually a mistake in the video. So this time we're going to be a little more careful, and I'll show you how in practice you should do it so that you don't make the sort of mistake I made. So uh, what we're going to do is try to find an antiderivative of this long, complicated function. As I said in our first iteration of the video, because all of these pieces are added or subtracted from each other, and we know that taking derivatives, and hence antiderivatives, uh, it doesn't matter if you have pluses or minuses. You can just take the pieces individually, take the derivative or antiderivative, and then sum or subtract them back up. So I'm going to handle these one pieces at a time. And I'm going to refer to my answer first as a guess because later on I'm going to want to check it. So the first piece, we have 50x to the 99. We want to find a function whose derivative is 50x to the 99. So because of the power rule for differentiation, I know that I need to start with an x to the 100th power. Of course, if I took that derivative, I would bring the 100 down. And so I don't want to have that 100 down. So I'm going to divide by it. And of course, I toss this 50 in because, well, there was a 50 here originally. Okay, again, I could simplify this to be 1/2. I also could have said, well, I know I'm going to bring 100 down, but I only want 50, so I could just start by dividing by 2. That also would have gotten us to the same place. All right, now the second piece, well, let's see, it's 3 over x. Now, I just pull the 3 out, and then I can think of this as being 1 over x. And I know that a function whose derivative is 1 over x will be the natural log of the absolute value of x. We put the absolute values here. That way, even if x is a negative value, we'll still be able to get some sort of an answer. The only problem we'll have is if x was 0, because you can't take the log of 0. But this function 3 over x wasn't defined at 0 anyway. All right. So our next function will be the 7 times 2x minus 1 to the 3/8. This is actually where there was a mistake. So first things first, there's a 7, which I can just put out in the front. All right, now I have 2x minus 1, which is not just an x. If it was just an x, I'd be super happy. But I'm going to pretend it was just an x. All right, in the sense that I'm just going to copy this like it was an x. And then I want to take a derivative to get down to the 3/8 power. So I'll need to put up here the 11/8 power, right? 3/8 plus 1. Because if I took the derivative, I would subtract 1 from this exponent and get to 3/8. Okay. However, I know I have to bring, if I took the derivative, this 11/8 down. And so I don't want to have that. So I'm going to divide by 11/8. Okay, so this looks a little complicated here. Okay, we also, if we wanted, could simplify this coefficient to be 56 over 11. Okay, next we are going to find an antiderivative for negative cosine of, okay, again, there's this piece. Wait a second, we forgot something, didn't we? We almost made a mistake again. We go back and say, well, okay, what happened here? I actually had a 2x minus 1. I was going to pretend I didn't have a 2x minus 1. But I do have a 2x minus 1, which means when I take this derivative, there's an extra 2 that's going to come out. So I also have to divide by 2 in order to compensate for the chain rule. Okay, so I actually, if I put this 2 down here, I'd end up with 56 over 22, right? Which, again, we could simplify, but I don't want to. Okay, so in the next one, I also have this extra 3x plus 4 business, but I'll just ignore that till the end. An antiderivative for cosine is sine, so an antiderivative for negative cosine is negative sine. So I'll have negative sine, and I'll just pretend I could put a 3x plus 4 here. And now if I took a derivative, I would end up getting an extra 3 because of the chain rule, and so I'm going to divide by 3. All right, let's see the next piece. I have an exponential function. Those are easy to antidifferentiate. All right, I'll put my times 4, and I just copy the function. All right, an antiderivative for e to the x is e to the x. Now, if I took a derivative, I'd get an extra 2, so I'm going to have to divide by that 2. All right, let's see. Now, this next piece looks very complicated, and this is where you need to know your differentiation rules. So if you know your differentiation rules, then you know that the derivative of the cosecant function is negative cosecant of x times the cotangent of x. Right? This is just one of those ones you have to learn. And once you do, you realize, oh, look, this cosecant cotangent, that's just the derivative of cosecant. I even have the negative out here already. Okay, so we're going to say, okay, let's say we'll do plus cosecant, but now there's a 3x, so fine. We'll do it of 3x. And if I took the derivative, I'd have to multiply by a 3, so I better divide by a 3. Okay, now this last one, this is another one where it comes from you knowing a differentiation formula. Namely, if you take the arctangent of x and take the derivative, you'll get 1 over 1 plus x squared. All right, well here I don't have an x squared, but I have a 5x minus 1 squared, so I just assume that it's going to work if I replace arctangent of x with arctangent of 5x minus 1. And then if I go to check it, I would get an extra 5, so I better divide by a 5. Okay, so let's go through and check our work. So let's see, this first one, I take a derivative, the 100 comes down and kills the 100 on the bottom, and I'm left with a 50, x, and then the exponent drops by 1. Cool. Okay, now I have 3 times the natural log of x. Derivative of ln of x is 1 over x, so this is plus 3 over x. Plus, okay, now over here are, there's just a jumbled mess, so let's rewrite it so that we know what it is we're talking about. So we ended up with, I guess, 56 over 22 times 2x minus 1 to the 11/8 power. All right, so first thing I do is I bring down the 11/8 when I take the derivative, and let's write it in. So I'm going to have 11/8 times 56 22nds, 2x minus 1, and then I have to subtract 1 from the exponent. That's 3/8 power. All right, now let's see if we can simplify this a little bit. So the 11 over 22, the 11 will cancel with the 22, and I'll end up with a 1 and an over 2. The 8 and the 56 will cancel. 8 becomes a 1, and the 56 becomes a 7. Okay, I might have said 52 before, I meant 56. Notice I'm not crossing out my numbers. Okay, this is a really good skill to pick up. A lot of teachers will cross out things, but I'll tell you what, when I'm reading, I don't want to have to try to read through your crossed out work. And when you read back, you don't want to have to read through it. Okay, so leave things as they are, write it on a new line, and okay, that's just going to be fine. Now, so I have a 7/2 down here. What else has to happen though? Oh, right, I had to use the chain rule on this, so I have to multiply by another 2. That's going to cancel this 2 in the bottom, and I'm going to be left with a 7. So in total, I'll have 7, 2x minus 1 to the 3/8 power. Hey, that's what we wanted. Okay, next, we're taking a derivative here. There's a sign. It'll turn into a cosine of 3x plus 4. We had a 1/3, but it has to get multiplied by 3 because we use the chain rule. Okay, so we're left with minus cosine of 3x plus 3. Let's see, this next one, we take a derivative of e to the 2x plus 1. By the chain rule, we'll get an extra 2. So I'm going to get minus 2 times 4 over 2 e to the 2x plus 1. The 2's cancel, and I'll be left with a 4 coefficient. Hey, that's what we wanted. Okay, next piece, we have to take a derivative of the cosecant. So the derivative of cosecant, as we saw over here, is negative cosecant of, in this case, 3x, cotangent of 3x. Then there was this 1/3 in the beginning, but it's going to cancel with the 3 we get by taking the derivative of 3x. Okay, and then finally, we take the derivative of the arctangent of 5x minus 1. Okay, there's a 5th out front. Arctangent derivative would give you 1 over 1 plus x squared. In this case, the x is 5x minus 1. So 5x minus 1 squared. There's a 1/5, but you have to multiply by the derivative of 5x minus 1. Again, chain rule, and those will cancel. Okay, and everything seems to have worked out fine this time.